Okay, so in this video we want to look at the cosine rule. And the cosine rule is the second rule that we can use when working with non-right angled triangles. So we introduced the sine rule in the previous video. So the cosine rule also connects the side lengths and angles of the triangles, but it will allow us to find unknown side lengths and angles if we have a different combination of information. So you remember the sine rule requires that we know a side length and its opposite angle. And it also requires that we are trying to find the side length opposite the angle we know, or we're trying to find the angle opposite the length that we know. So it won't always work. So if we think about this triangle, for example, okay, this does meet that initial criteria in that I've got an angle and its opposite side length. So the sine rule could be useful to me. But given that I want to find this angle, I need the opposite side length. Now, what I could do is I could use the sine rule to find that angle up the top using the 8 centimeters and then subtract from 180 to find this. So it's possible to get there in the long run, but the sine rule isn't immediately helpful. Okay. The other issue here would be if, for example, I didn't have that side length, but I had this side length, and I knew that was 7 centimeters, for example. Okay, so this time I know the side length opposite the angle I'm trying to find, but I now have, so we're assuming we don't know that, I now have this problem that I actually don't have that important combination for the sine rule, which is an angle and the opposite side length that I know. Okay, so that's actually going to be the most common issue where we're going to need to use the cosine rule, but this is another example where we'll need it as well. So sine rule doesn't work here. We don't have the right combination of information. So we're going to introduce another rule, cosine rule. I'm going to work through establishing that rule here. You don't need to be able to do this, but you can just listen and follow through. That's great. If you get a bit lost, that's okay too. You just need to be able to utilise the rule in further maths. So we're going to start with that same scalene, so 3 different side lengths, acute angled, so all the angles are less than 180, triangle. It's called ABC. We're going to use that same notation, lowercase letter, uppercase, lowercase letter for the length, same uppercase letter for the opposite angle. And we're going to do what we did back in when we were establishing the rule for the area of a triangle, and that is to drop a perpendicular from C to a point that we're going to label P. Sorry, so it's not from C, it's from B in this triangle, my apologies. So we're going to drop it from B, we're going to drop it perpendicular, so that means it's at a right angle to the base of the triangle. And we're going to call this P where it meets with the base, we're going to call that point P. And we're going to label this H. This is the height of the triangle. Okay. So what we've done by doing that is we've divided our triangle into 2 right angled triangles. We used this exact same technique when we were establishing the rule for the area of a triangle. And as I said, this is not something you need to do. We're just working out the rule. And then once we've got the rule, we're going to be able to use the rule. So we've divided it into 2 right angled triangles, purple and orange. So in the triangle labelled APB, so that is the purple triangle, okay, we can use Pythagoras Theorem. So a couple of things I've done before we can do that, sorry. So we've got H is our height, okay. Now we know this whole length here is B, but that's not helpful in my orange triangles. So I'm going to label my orange and purple triangles. I'm going to label that as X, okay, and therefore that would mean that this bit of length left here in the purple triangle has to be B minus X. So when I use Pythagoras in the purple triangle, I know that c squared, which is the hypotenuse of the purple triangle, is equal to h squared plus b minus x squared. And I can expand out these brackets to get b squared minus 2bx plus x squared. I'm going to leave that there for a minute. Then if we look at the orange triangle, CPB, okay, we use Pythagoras' theorem in that triangle too. So in that triangle, a is the hypotenuse length, so a squared is equal to h squared plus x squared. And if I rearrange this to get h squared on its own, so I'm subtracting x squared, h squared is equal to a squared minus x squared. And then what that means I can do is if this is equal to h squared, over here in this first equation, I can replace h squared with a squared minus x squared, which I've done here. And when we do that, we see that this minus x squared and this plus x squared, well, they cancel each other out. And so we've just now got this connection here. C squared is equal to a squared plus b squared minus 2bx. Okay, so we're trying to get rid of the x's out of these equations because we're not going to know what that x length is. We're going to know a and b and c and an angle and angles, but we're not going to know x. So we're trying to get rid of x. So you see in this first equation, and we're also trying to get rid of h, it's not a side length. So we got rid of h out of this equation, and now we need to get rid of x. So then we're going to triangle CPB, so CPB is the orange triangle, we're going to use trigonometry in there. Okay, and trigonometry tells us that cos of C is equal to the adjacent side length over the hypotenuse, so x over a. And again, I can rearrange to get x on its own by multiplying both sides by a, and I know that x is equal to a times cos of c. And then if I know that x is a times cos of c, then in this equation here, I can replace x with a times cos of c. And so I've done that here, and so now I get this, which is my cosine rule. C squared is equal to a squared plus b squared minus 2ab times cos of c. Now, if we'd relabeled the triangle and instead called this side A and this side B and this side C, we would have got a slightly different version of the formula. Okay, it would have had cos B in it instead. Okay, and again, if we labelled again, we could have got it with cos of A. So I don't want you to get bogged down again in what is A and what is B and what is C. I want you to focus on how these quantities connect with each other. And the most important thing is that whatever angle you have, if you're going to use angle C in the cosine, you have to use side length C on its own on the left-hand side of the equation. Okay, these things have to be partners. Okay, that's an angle and its opposite side length. The other things don't really matter. Okay, the other things, this is just the other two side lengths squared and added together. Now, if we wrote that as b squared plus a squared, that's still the same thing. Okay, so it doesn't matter which way around they go. And then this is minus 2 times the other two side lengths multiplied together. And again, if we did b times a, that's still the same thing. So the key thing is to get this combination right, the angle on one side of that you're going to use on one side of the equation, and its side length on the opposite side of the equation. And then everything else will fall into place. Okay, so again, don't need to worry about what's A, what's B, what's C. Let's focus on how it all works together. All right, find correct two decimal places the length of the unknown side. Okay, so let's call this unknown side x. Now, the 64 degrees is going to drive the whole way that we have to set up our equation, our cosine rule, okay, because we only know 64 degrees, and so we have to be able to use cos of 64 degrees in our formula. And so therefore, based on what we talked about up here, if I want to use 64 degrees in the cosine, I have to use the side length opposite the 64 degrees on the left-hand side of the equation. So it has to be x squared on the left-hand side. Okay, so then it's the other two side lengths squared and added together. Doesn't matter which way around they are, because 7 squared plus 9 squared is the same as 9 squared plus 7 squared. And then it is take away 2 times, we multiply those two side lengths together, 7 times 9. Again, 9 times 7 is the same as 7 times 9, so it doesn't matter which way around we do it, times cosine of 64. Okay, so let the angle define how you set it all up, and then it's just about working it out. Okay, now we could use our CAS to solve, but again, we've pretty much got x on its own. X is going to be the square root of all of that. 7 squared plus 9 squared minus 2 times 7 times 9 times cos of 64. And so we can put that in our calculator. Square root of 7 squared plus 9 squared. Sorry, the computer version of the CAS always puts the cursor in strange places. Alright, 7 squared plus 9 squared minus 2 times 7 times 9 times cos of 64. Control Enter. We want two decimal places, the length of the unknown side. It's approximately 8.65 centimetres. Alright, and again, you know, that sort of does make sense thing. Yes, I'm happy with that in the scheme of this triangle. 64 degrees isn't far off 60 degrees, so it's sort of looks like, and these side lengths are similar in length, which would mean that these two angles are sort of similar in size. So it's vaguely equilateral, or close to an equilateral, I should say. And so I'm quite happy with the unknown side length being somewhere in the vicinity of 7 to 9 centimetres. We could solve right from here if you want. Menu 3.1, solving x squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times cos of 64. Solving that for x, Control Enter. You'll notice we do get two solutions here, but they're not both valid because one of them is negative and x is a side length, so I would ignore the negative solution, and x is 8.65 centimetres as we found. Okay, so either this one little thing of solving yourself by just taking the square root and then working out the square root of all of that, or get your CAS to solve, either way. Okay, question 2. In triangle ABC, angle A is 52, and length A is 10, and length B is 7. Find C, correct 2 decimal places. Okay, again, let's draw a triangle. Scale doesn't really matter. That's 52 degrees. That is 10 centimetres. This is 7 centimetres. Okay. So unlike in this previous example, I should have noted, the sine rule was definitely out because we didn't have a combination of angle and its opposite side length. We need one set of that at least where we know the angle and its opposite side length, whereas that opposite side length is unknown. So in this case we do have that, and so we could use the sine rule to find this angle over here, but that's not the angle we're trying to find. So let me just label this. This is A, that's B, and that's C. So we could use sine rule to find this angle here. Okay, sine of B over 7 is equal to sine of 52 over 10, and then subtract from 180 to work out what C is. That would be possible. So the sine rule is an option here, but we could instead use the cosine rule if we just want to get straight to the answer. So we're trying to find angle C up here. So I'm going to need in my equation to have cos of C, because that's the angle I want to find. And so therefore, I'm going to need the side length opposite that, which actually I don't know. Sorry, I completely misread the question. We're finding lowercase c, so we're finding side length c. So it's not the angle that we're trying to find, it's this side length that we're trying to find. Okay, so we're not interested in finding the angle, which is a good thing because we didn't have the information to do it. Although we could have used the sine rule. We want to find this side length c. We've only got one angle, 52 degrees, so we're going to need to use that in our equation. So we're going to have to use cos of 52 degrees. So if we're using cos of 52 over here, that defines that we must have 10 squared on the left-hand side of the equation, because remember, those two things have to be a partnership. And then everything else just falls into place. So then it's going to be the other two sides squared and added together, so c squared plus 7 squared, or you can write 7 squared plus c squared, it's the same thing, minus 2 times c times 7 times cos of 52. Or you can write 2 times 7 times c times cos of 52, it's the same thing. So setting up your cosine rule, then we're going to need to solve for c. Now we can't solve this by hand, you've got c in two different places, we'll just get our CAS to solve it right from the outset. So menu 3.1 for solving, 10 squared equals c squared plus 7 squared minus 2 times c times 7. I know this is a complicated formula, but you'll find once you use it a bit, you do get used to it, and it's sort of not that complicated. So it's all about practice. And so solving, that's my equation, comma c, I want to solve for c. Control enter to get that as a decimal. Again, we've been given two solutions, but one is negative and c is a side length. And so we can say, therefore, that c has to be, what do we want, 2 decimal places? 12.65 centimetres. And again, I'm happy with that as an answer that seems reasonable in the context of this triangle. Okay, question 3. This time it's an angle that's unknown. So in question 1, it was a length that was unknown, but it was the length on the left-hand side of the equation. In question 2, it's a length that was unknown again, but it's a length that's on the right-hand side of the equation. It's a slightly more complicated equation, but when you've got your CAS, neither is more complicated than the other, you just get it to solve them for you. Here, we've got an angle that's unknown, okay? So again, sine rule is not going to be useful to us here because we need to know at least one angle to use the sine rule. We would need to, for example, know this angle, so we had this combination of information. Or we'd need to know this angle, so we had this combination of information. If we don't know any angles, sine rule is not an option at all. We're going to need to use cosine rule. That's the angle we're trying to find. So we're going to want to have cos of that angle in our equation. And so therefore, that defines what has to go on the left-hand side of the equation, which is the side length opposite that, and so that is 7. So we're going to need 7 squared equals times cos theta. Alright, then everything else falls into place. 3 squared plus 8 squared, or 8 squared plus 3 squared, minus 2 times 3 times 8 times cos of theta. Alright, we get our CAS to solve for theta, and we're going to find we have the same problem we saw in the previous video with the sine rule. So if I solve this, 7 squared equals 3 squared plus 8 squared minus 2 times 3 times 8 times cos of an unknown angle. Just use x. Finding a Greek letter is more complicated than it needs to be. Solving for x, comma x. If I press Control Enter, it's going to give me this general solution thing again. Again, there's infinitely many solutions. If it's the angle we're trying to find, which it is, we're going to need to give our CAS some sort of restriction about that angle. Now in this case, we don't know any of the other angles, so all we know is that theta is going to have to be somewhere between 0 and 180 degrees, but that's still a restriction. So given that 0 is less than, so remember the given that goes outside of the function, so close off the bracket for the solve function. Then, given that 0 is less than, now we've called it x in the CAS, it's less than x, which is less than 180. Control Enter now, it will give me the only solution that is actually between 0 and 180. And so in this case, theta, now again be careful, even though I used x in my CAS, don't write x on the paper, there is no x in this problem, it's all about theta. Okay, so theta is a nice exact answer here, exactly equal to 60 degrees. Okay, again, some instructions here about solving equations involving trig ratios using your CAS, in particular when you need to use given that in order to find a particular solution, when you're finding an angle, sorry, and making sure that it goes after the solve bracket. Alright, let's just do two more. Find the length of AB, correct to two decimal places. Okay, so AB is this length here. We would also call that lowercase c, opposite angle C. Again, we do have that nice combination of information here that suggests maybe the sine rule is a possibility, but we don't know this angle up here. So we don't know the angle opposite the length we're trying to find, although again, we could find this angle here with the sine rule, using that combination, and then subtract from 180 to find this angle, and then use the sine rule for this, but actually that would require, 3 separate calculations when we could just go straight to the cosine rule. Okay, let's focus on what we've got. So 31 degrees we're going to need to use. So we're going to need cos of 31 degrees. That therefore defines if I've got 31 degrees in my cos, on the left-hand side of the equation I must have the side length opposite the 31, which is 8. So 8 squared equals c squared plus 15 squared minus 2 times c times 15 times cos of 31. And we'll get our CAS to solve that. NU 31. 8 squared equals c squared plus 15 squared minus 2 times c times 15 times cos of 31, comma c to solve for c, control enter to get our answer as a decimal, and in fact we find that we have an ambiguous case again. So we have c could either be 10.78, 2 decimal places, yep, 10.78 centimetres, or it could be 14.93 centimetres. Okay, so again, there's 2 possibilities, and that's because Sine Rule would tell us that we could swing that length around there and create 2 separate triangles. Okay, so there could be the larger purple triangle, which has got an acute angle here and the longer length. Okay, so that would be where it's 14.93, or we could have this smaller triangle here where we have an obtuse angle and that's a shorter length, and so that is 10.78. Okay, so there are 2 possible lengths for C. We've been given an ambiguous combination of information. Okay, question 5, find the value of alpha correct to 1 decimal place. So this is the angle we're trying to find. There's only one angle in the cosine rule, so it needs to be the one we're trying to find. Cos of alpha, and again the angle in there has to match up with the side length on the left hand side of the equation, so this has to be 9 squared here, and then it's just the other 2 squared and added together, 6 squared plus 11 squared, or 11 squared plus 6 squared, minus 2 times 6 times 11, or minus 2 times 11 times 6 times cos of alpha, and we're going to need to solve for alpha. So we can solve 9 squared, and you can of course take some shortcuts rather than type in 9 squared. If you can write 81, you know that 9 squared is 81, you can equal 36 plus 121, doesn't really matter, but you just need to solve your equation. Minus 2 times 6 times 11 times cos of x, comma x, and because we're solving for the angle, we will need a restriction. And we don't have any other angles in the triangle on this occasion, so all we know is that alpha, or x as it is in my CAS, has to be somewhere between 0 and 180 degrees in order for this triangle to exist. Control Enter. This time we just get one value for alpha. So alpha is 54 point, what do we want, one decimal place, 54.8 degrees. Okay, exercise 18C for today's work.